Welcome to lesson 8 of AP Calculus AB. We're going to do 2 mini sections of trigonometry review, and we're going to focus on the unit circle. The next lesson will be some other things like cosecant, cotangent. Right now, we're really just looking towards sine, cosine, and tangent. Well, let's kind of go back to some of the basics. Say, for example, let's just do number 1. Below, translate the following radians into degrees, just so that you guys kind of know the basis. One way to do it is to multiply by 180 over pi. And so if we do that, and this is your ratio because 180 degrees is equal to pi. So we're going to get that cross 180 divided by 2. So this is 90 degrees. So you know that pi over 2, 90 degrees, that's going to be the same thing. Okay, let's head down to number 2. 180 over pi, bam, bam. And then we'll just go 180 divided by 4, and this is going to be 45 degrees. Okay, so pi over 4, 45 degrees. Pi over 2, 90 degrees. Let's do pi over 6. Okay, bam, bam, 180 divided by 6, that is going to be 30 degrees. Okay, pi over 6, same, 30 degrees. Last but not least, okay, 180 divided by 3, then this is 60 degrees. So pi over 3, 60 degrees, they're equivalents. Okay, the importance of this is because we're going to be using pi over 2, pi over 4, pi over 6, and pi over 3 as what's called our reference angles, and we're going to refer back to them when we do some of our evaluating these functions. We're going to compute the following. These will be your reference angle values to help you with the higher radians. And we can also sketch our 45, 45, 90 degree triangle and 30, 60, 90 triangle to help us with these values. So, and this is from geometry. Let's use, like, I guess this bottom area over here to draw those triangles. So let's go ahead and do that. Maybe this could be our 30, 60, 90. So 30 degrees, 60 degrees, and then 90 degrees. And then let's make this our 45, 45, 90. Okay, back in the yonder geometry days, and oh shoot, let me just zoom in a little bit. Back in the yonder geometry days, these were our special right triangles, and they had patterns to this. You know, when we have these specific values of these angles. I do want to emphasize, and I want to put some color in here. Again, 30 degrees, this was pi over 6. 60 degrees, this was pi over 3. And then our 45 degrees was our pi over 4. Okay. These were the values of this. Across the 30 degrees, by next to the 60 degrees, the pi over 3, this is a value of 1 unit. The hypotenuse is a unit value of 2. And by the 30 degrees, or the pi over 6, that is square root of 3. 1, 2, square root of 3. Right next to the 30 degrees, square root of 3, pi over 6. For the 45, 45, 90 degree triangle, your basic values are going to be 1, 1. So this is an isosceles right triangle, and the hypotenuse is going to be square root of 2. So once we have this over here, we can start actually getting some of these values here. Okay, I'm also going to draw like a portion of the unit circle, and don't worry, I'll just kind of draw. I'll give you guys the whole thing, and then this is 1, 0 here. And the reason why I'm just drawing this portion here is because and this is 0, 1. This is your pi over 4. This is your pi over 6, or 30 degrees. And then I guess your pi over 3 will be over here. Okay. And then they make these triangles like this. Okay. All right. It's just a rough sketch. So yeah, pi over 3, pi over 4, and then pi over 6. Okay, I didn't draw it to the best of my ability, but the first question is, why is sine of 0? And I want to put parentheses here. Sine of 0 is equal to 0. The reason for that, if I can make a very, very quick reasoning, is because if we were trying to make a triangle over here at 1 comma 0, I do want to remind you that sine is opposite over hypotenuse. So when we're doing sine, sine of 45 degrees will be opposite over hypotenuse. Well, if you take a look at this line over here at the 0 degrees, it's really hard to picture. It's super, super hard to picture a length of, of 3 sides, okay? So here's 0 degrees here. Remember, sine is opposite over hypotenuse. Well, there's no height over here, and the height is 0, okay? So 0 over, and I guess the hypotenuse could be a 1, 0 over 1. I mean, that's just going to be 0 over here, okay? So I'm asking you guys from numbers 5 to number 9 to actually evaluate these functions, and then, but I do want to propose a small, not shortcut, but then it's kind of like a revelation of sorts. So I think what I want to do is I think I want to make a chart here. Sine of 0, sine of 30, sine of 45, sine of 60, and then sine of 90. A revelation pattern, I guess, if you guys want to call it that way. Call it that. Again, 30 degrees is pi over 6, so I think I should be writing also the equivalent pi over 6, pi over 4, sine of pi over 3, and this is sine of pi over 2. Okay. I'm going to show you guys some really cool thing. What I'm going to do is I'm going to write this little square root of 0 over 2 right over here. Then after that, I'm going to write square root of 1 over 2. Then I'm going to write square root of 2 over 2. Square root of 3 over 2, and then square root of 4 over 2. So you see that pattern, square roots on the top, and just the 2 on the bottom, okay? So now when we evaluate this even further, when we simplify this even further, square root of 0 over 2, that's just going to be 0. So sine of 0 is 0, okay? Sine of 30 degrees, or sine of pi over 6, square root of 1 is 1, so this is going to be 1/2. Sine of 45 degrees, or pi over 4, well, we can't really do too much, so this is square root of 2 over 2. Very similar to sine of 60 degrees, or sine of pi over 3, this is going to be square root of 3 over 2. Okay. Well, square root of 4 is positive, so it's going to be 2 over 2, so 2 over 2 is going to be 1. Okay. So that's I guess a small pattern, I guess, trick or revelation that you guys can use. So you guys can do numbers 5 through 9 on your own, even though they're already in order. Let's go to the next page now with cosine. Cosine, I also want to show you that same chart, and then you guys can fill in numbers 10 all the way to 14, even though I think I'm already filling it up for you. So I think I'm going to do the same thing. Cosine of 0. Cosine of pi over 6. Cosine of pi over 4. Cosine of pi over 3. And then cosine of pi over 2 are 90 degrees. So let's just make that chart, and then maybe I can show you guys a small revelation. For the cosine revelation, it's going to be backwards. So what I mean by this is I am going to do, for cosine of 0, I'm going to do square root of 4 over 2. Okay. Then square root of 3 over 2. Square root of 2 over 2. square root of 1 over 2, and then square root of 0 over 2. Well, square root of 4 is 2, so 2 over 2 is going to be 1. So now cosine of 0 is 1. Okay. Cosine of 30 degrees, or pi over 6, well, we can't do too much. That's going to be 3 over 2. Cosine of pi over 4, or 45 degrees, that's going to be square root of 2 over 2. Cosine of 60 degrees, or pi over 3, the square root of 1 is 1, so that will be 1/2. And then afterwards, cosine of 90 degrees, it will just be 0, square root of 0 over 2, so that's going to be 0. Okay. All right, so you guys can do numbers 10 to 14, even though they're already in order of that. Okay. Tangent, there's a couple ways you guys could do this. And those couple ways is, I do want to remind you guys that one way you could do tangent is you could split it up as sine of 0 over cosine of 0. Okay, and then from there you can get the values. Sine of 0 is 0, cosine of 0 is 1, so then tangent of 0 is going to be 0. Okay, so that is one way. Another way is to use your reference your triangles. Tan of pi over 6, that's tan of 30 degrees. And so let's go take a look at your triangle, tan of 30 degrees, or pi over 6, which is right over here. Remember, tangent, I have the SOHCAHTOA, I have the acronyms here. It is opposite over adjacent. So opposite over adjacent. So 1 over radical 3. And then we can multiply top and bottom by radical 3. So this is going to be square root of 3 over 3. Okay. Usually when it's tangent of zeros or the 90 degrees, that's when I split them up into sine over cosine. Okay, and then we have values from this based on the notes. Sine of pi over 2 was a 1. Cosine of pi over 2 from this chart over here is a 0. We cannot divide by 0, so this is going to be undefined. Okay, please fill in the rest, but I'm going to see you guys on the next video.